Hello and welcome to another class on periodic properties of elements. In the long form of periodic table that we are discussing now, we have completed atomic size, ionic size, both cationic and anionic, how we can explain through effective nuclear charge, Z star, using the Slater's calculation theory for calculating the screening constant and then the effective nuclear charge. We started to discuss ionization enthalpy, and we had completed also how the ionization enthalpy varies across a period. It increases across a period. As size decreases, the nuclear pull increases, the effective nuclear charge increases. It becomes increasingly difficult to knock out the outermost electron from the atom. So IE increases. Down the group, the ionization energy decreases, although the effective nuclear charge remains constant. Have you checked with one group how Z star remains constant? Have you seen that?
Yes, sir.
Yes, sir.
Maybe barring somewhere a bit of exception. You might find a bit of exception somewhere, but in most cases, among normal elements, it remain more or less constant. Mm, but the N factor, because the force of attraction, the nuclear pull doesn't depend only on the Z factor. Z star E square by R square. R is dependent on N, the radius. Therefore, the ionization enthalpy decreases as size increases. But what happens to this ionization enthalpy in D block and F block, that we have not yet discussed. Today we'll be discussing that. But before that, let me ask you, I had given you to find what is the sigma for 6s. Tell me how much you got, Mr. Swam, for platinum. Sigma.
Sir, 74.45.
Is it okay, Mr. Tripathi?
Okay, sir.
So Z star kitna आया? Which is 78 minus 74.45. See how small it becomes. It is 3 point, how much?
55.
Do you have the same value, Mr. Tripathi, or you are saying yes, sir? Koricho na nahi?
Okay, sir.
So here for 6s you don't have anything. For sigma it is 0 plus, because one electron has to be left out. And there is no other screening electron in the same valence shell. So then we start the inner, all the n minus 1, 9, 6, 15 plus 2, 17. 17 plus 17 into 0.85. Then you add everything, n minus 2, n minus 3, all things together into 1. I don't know how many into 1. So that gives you, as you told, 74.5 and this one. And what about a 5D electron? Sigma for a 5D electron, this 6s has to be ignored. So this will be 8 plus 1. Yes or no?
Yes, sir.
So 8
Yes,
into
sir.
0.35. Remember, this is the last group. The D group is a separate group. 8 into 0.35 plus all the lower groups. These are lower groups. All taken together is no 0.85 here into 1. So whatever you get, that is the screening constant for any D electron, 5D electron, I'm sorry. And if you are going for 4F, all these outer electrons are ignored. So this will be 1 plus 13. So 13 into 0.35 plus the remaining out from 4D downwards up to this, that into 1, that gives you screening constant for a 4F electron, and then you can find effective nuclear charge. Have you done that?
Yes, sir.
Yes, sir.
Now, what Mr. Tripathi has asked me to find out or to explain to him why, supposing we are again discussing the case of iron, this will be 1s2, 2s2, 2p6, 3s2, 3p6, then 4s2, 3d6. So for S, 1 plus 1. And for D, this is to be ignored, 1 plus 5. Perhaps he wants to know the reason why when D was inner cell, 0.85 was being bestowed upon it as a screening constant. And when it becomes the orbital whose one of the electrons we are finding, what will be the screening constant? For that, why it is again 0.35? Now see, for 4s, 3d is a inner electron, inner shielding electron. In the true sense, it is radius wise, it is less. So it is screening more than what it would have done. What the 4s, the other 4s electron is doing. Supposing for 4s, the other, the one electron which we have taken 0.35 is the electron present in the same subcell, same orbital, or say same group, the same cell, not in a previous cell. So the electrons present in the same group, same cell, they are together. So the only small little repulsion effect will be responsible for the screening. But the lower cells screens more, not merely the repulsion, but mechanical screening, just like a screen. Mechanically, you have put it so that it acts like a dielectric substance, a dielectric substance, as if to reduce the attraction between the positive pole nucleus and the negative pole, that is the outer electrons. So when you are finding the screening constant for D, it has two meanings. One is the reality that actually there are no 4s electrons. For example, ferric. You have already removed all the two 4s electrons. Then the outermost subcell is D. So when it is an outermost, you are finding screening constant for a 3D electron. And as per rule, the outer electron will not screen the inner electron, which really means it is not there. In actual sense, you are finding for ferrous, at least for ferrous, where the outer electrons are not there. Or in case of platinum, when you are going to find for a 4f electron, it is theoretical, it doesn't carry any meaning. Just explaining that 4f is deeply inside. 5d is there, 6s is there. So the 4f electrons, if you are finding the screening constant for any 4f electron, then these will not be there. Only 13 plus 1, 13 in the same orbital. Together, they will not screen much. They will screen 0.35 per electron. Because you are finding for a 4f electron. Had you found for a 5D or 6s, then 4f would have shown, 5D, it is all 1. If it is 6s, it is, five, all the five are 0.85, and the previous ones are all 1. So why 1 and 0.85? It's because as you go, if it is very near to the ultimate cell, the ultimate, particularly the ultimate cell belonging to the S and P, whose penetration is more, screening is relatively more. More the penetration, more is the screening is more. In that case, we take, for all the n minus 1, we take 0.85. Screen little bit less than the previous ones, and quite more than the ones which are present in the same SP group. 0.35 से ज़्यादा, 1 से कम. But as you go, but away, farther away from the electron whose sigma you are going to find, then they screen much greater. Much greater means greater, little greater, and all of them will have the same effect. N minus 2, n minus 3, but only difference will be the n minus 1 for S and P. S and P enjoy a special status of having, greater penetration and hence greater screening. So when you are finding screening for any S electron or P electron, in that case, as usual, 0.35 will be the contribution for the electron in that group. But n minus 1 D, which has got a poorer screening effect than S and P, will be producing, will be, having a, screening effect lower than the nth electron, which is 0.35, but greater than the n minus 2, n minus 3. But once you are going for any D, 3D, ignoring 4S is absent, or it is there, we theoretically are going to find. So in that case, 3D, once it is the outermost one, for the remaining electrons, it is 0.35. But before that, 3p comes, 3s comes, and all these, even if they belong to 3, the same principal quantum number, we give 1, because S and P, they have huge penetration, much greater penetration, having angular node, and if it is 4D, then it has got one radial node. So because of the greater penetration and greater screening effect, therefore for all of them we give 1. I think it will suffice. Okay.
Yes, sir.
So am Bujila what I said?
Again, sir.
Now we are set to finish out a page, Koriba. As I told you that I have no such uh, reservation or any obsession to have the class in English. Now, whenever I feel that I am not able to access you properly, you are not able to understand properly, then I will come down to any language, preferably Odia. Now we will take up ionization enthalpy continued. We discussed that how the knowledge of IE1, IE2, IE3, IE4, I5, this data for a particular element will make you determine its oxidation state or valency when there is a drastic jump from a lower value to a higher value, particularly more than 3 times, 4 times. Then you feel, you know that many data that you have surpassed, that many electrons are there in the valence cell, and hence that's the valency. And we also found that in a what? In a, I need a periodic table to be imported every time. Okay. So we have discussed that in periods, we get a hump. The first hump in group 2, it increases, no doubt. The trend is increasing. You are climbing the mountain slope, a hill slope, but in the hill slope, you find two humps. In the hill slope, ascending hill slope, you get two humps. One here, other hump is group 15. So that the succeeding element becomes lower than that sitting on the hump, but not lower than the previous one, which is just one place behind the element sitting on the hump. Oxygen is lower than nitrogen only, but not lower than carbon. So you have made an order. So for the third period, so for the fourth period, ignoring these elements, potassium less than gallium, less than calcium, germanium less than selenium, then arsenic, then bromine, then krypton. We have done it. But such anomaly will not be found here. Rubidium less than strontium, less than indium, less than tin, less than lead, less than tellurium, and it continues. But in the sixth period, there is a little anomaly which we have studied. Cesium less than barium, less than thallium, less than bismuth, less than lead, less than polonium, astatine, radon, because of the lanthanide contraction effect. Though the severe brunt goes to thallium, but lead next. So much so that lead has greater IE than tin and also greater IE than bismuth. I will show you the table after I complete what is the train. So I think we have written that, have we?
Yes, sir.
Lead ರ I eat a greater than bismuth in sixth period लिखीचे बोधे नहीं स्वयं
आगे आगे
स्वयं
तो लिख रही
Again,
सोइलेंडी.
sir. Again, sir.
So before going into the D block and F block, let us trend along groups. When I say IE, I means IE1. Nobody says I1, I1. IE means IE1. But when you compare between I1, I2, I3, then you have to mention I1, I2. Now see, in a group, it decreases due to the N factor. The reason is due to decrease in nuclear pool. Not due to effective nuclear charge, but due to the N factor, the radius factor that you know. But anomalies. You will find anomalies in the P block. There is no anomaly in the S block. In the P block, because of the D block contraction effect or Scandide contraction effect, which you already know, that is the middle row anomaly, and also the F block contraction, particularly the lanthanide contraction that we studied in the last class, we have a severe anomaly, particularly group 13 or 3A boron family. It goes on decreasing, but boron greater than, who can tell me? Which element comes next to boron? I've told you several times. Yes, Swayam kuh. अरे कुह
Sir, beryllium.
हैं
Sir, beryllium.
बेरिलियम कोड आसला मो गैलियम ठीक है देखो बोरॉन तार सीक्वेंस होची बोरॉन एल्युमिनियम गैलियम इंडियम थैलियम निहोनियम को मारो गोली यस मिस्टर त्रिपाठी
सर बोरन गैलियम और तापर एल्युमिनियम
तुमे भूली जाउଛ ଯେ ମୁଁ ତିନି ଥର ଚାରି ଥର ଖଣ୍ଡେ କହିଛି ବିକଜ ଅଫ ଦ ଏନ୍ଥରାଇଡ୍ କଣ୍ଟ୍ରାକ୍ସନ ଯେତେବେଳେ ମର୍କ୍ୟୁରୀକୁ ଛାଡ଼ିକିରି ଏଇଟିକି ସାରିଲା ପରେ 81 को ଥାଲିୟମକୁ ଆସିବା ଇଟ୍ ହାଜ ଏ ଭେରି
सर
ହାଇ
बोरन थैल आगे सर
ଏବେ
बोरन थैलियम गैलियम एल्युमिनियम
yes ଏବେ ମନେ ପଡିଲା because of the lanthanide contraction thallium gets the greatest brunt it has so high ionization enthalpy that it is second highest in its group କହିନି स्वयं स्वयं
Yes, sir.
so boron ପରେ କିଏ ଆସିବ
Thallium.
thallium it is because of the lanthanide contraction effect ମାନେ post lanthanide elements ମର୍କୁରୀ ପର୍ଯ୍ୟନ୍ତ ପରେ ପୁଣି ଥାଲିୟମ ପର୍ଯ୍ୟନ୍ତ ତାର ପ୍ରଭାବ ଜୋରସୋରରେ ପଡିବ lanthanide contraction ତାପରେ କିଏ ଆସିବ
सर गैलियम
gallium then କିଏ ଆସିବ because
सर
gallium has
एल्युमिनियम
greater because of the d block contraction gallium has a slightly greater size wise same थिला किबा बहुत जगह size टिके बढ़ुथिला similar ବୋଲି କହୁଥିଲେ ଆମେ but distinctly ionization enthalpy of gallium is greater slightly greater than aluminum so gallium ତାପରେ ସବୁଠୁ କମ ହଉଛି କିଏ indium we will see this strain this is due to the d block contraction or scandide contraction middle row anomaly so whatever you can write then coming to group 14 gotte change ଅଛି कार्बन greater than silicon greater than germanium तापर किए
सर लेड
लेड
Lead.
ସବୁଠୁ କମ ହଉଛି ଟିନ୍ ମୁଁ କହିଥିଲି ଲେଡ୍ ସେଇ ପର୍ଯ୍ୟନ୍ତ ଲାନ୍ଥେନାଇଡ୍ କଣ୍ଟ୍ରାକ୍ସନ ଏଫେକ୍ଟଟା ପଡୁଛି ଯଦିଓ ଥାଲିୟମରେ ବହୁତ ପଡୁଛି ଲେଡ୍ରେ ତାଠୁ କମ so much so that it is only greater than tin not second highest only greater than tin in the same group and also greater than bismuth in the same period so ଏଇଟା ହେଲା ଆଉ ଅନ୍ୟ କୌଣସି ଗ୍ରୁପରେ anomaly ନାହିଁ okay then coming to the D block it's not like you will find completely surprising trend which will not match with radius why it will not match let me tell you that the radius that we determine we do not determine from an isolated atom the experimental determination of size is through solid state crystal we find the internuclear distance then divide by 2 in either metallic radius or covalent radius in bonded state what I mean to say in the bonded state but ionization enthalpy is determined in the unbonded state in isolated gaseous atom we have to make any solid or liquid or even diatomic triatomic gas into monoatomic and vapor if it is sodium or iron you have to heat it not to its boiling point but under reduced pressure in the vacuum condition it will vaporize at lower temperature so you have to convert it into vapor and iron when it is vaporized at low pressure it becomes atomic monoatomic only when it is in the condensed state sanghanana avasthare liquid kimba solid state they are associated with some metallic bond if they are metals metallic bond comes in but in the vapor state of same metal There is no metallic bonding. Isolated iron atoms, sodium atoms, aluminum atoms, bromine atoms. Bromine is a non-metal, but it remains as Br2. So the bond is broken. And then the voltage is increased. Slowly increased till the first electron is removed. And again slowly increased till the second electron is it gives in a spectrum a high a peak comes when suddenly one electron is knocked out, then second electron. So increasing the voltage in a very regular and systematic manner, they find I1, I2, I3, I4. These are all in the isolated case, atom case. But radius, that is why in a series, the ionization enthalpy in a D series is very erratic, but you will find it increases. The trend is increasing like any other normal period, but in an erratic manner. But the most important thing is at the end of any series, the IE is highest in the respective series. For example, in the first series, zinc has the highest. Second series, cadmium has the highest. And in the third series, the mercury has the highest. But down the group, you will find interesting observation. In this series, you will find that zinc has the highest. But when you jump from zinc to gallium, 30 to 31, you will find a sudden there is a decrease because you will be removing electron from the 4p, not 4s. For all the transition series elements, 3D from scandium to zinc, you remove electron from 4s. Although you get the increase in electron in the D, but actually for finding IE1, you remove electron from 4s. So why there is an increase? So far as the size is concerned, we found that it decreases up to certain level, or as per the graph of the NCRT that I gave you, it goes on decreasing drastically or more sharply in the initial elements. Then the decrease is very slowed down, and it comes to a minimum point like nickel, and then it increases copper, zinc. That same thing happens the other two graphs, but the other two graphs are very close to each other, excepting scandium and lanthanum, which you know no sorry lanthanum yttrium and lanthanum, they have different size. There is a gap, but after that the two graphs, they are very close to each other, very close to each other, but the same trend you will find. With ionization energy, you will find erratic, goes on almost increasing and increasing. Finally, it becomes the highest in the respective period. So one in series wise increases, irregular, but highest in the last element. For example, 3D series ray, zinc highest, 4D series ray, you will see all these. Cadmium highest, 5D series ray, mercury highest. How copernicium, nobody has done any research on. It is a very unstable and synthetic element. এই তিনটা কথা আমি চিন্তা করিবা। But group wise, you know, vanadium group, chromium group, nickel group, 5, 6, and this is 10. These groups, it increases down the group, increases down the group. So that means vanadium less than, tell me, less than,
Niobium.
yeah, less than
tantalum,
tantalum.
Tantalum.
Similarly, chromium less than
molybdenum,
molybdenum, less than
tungsten,
tungsten. Nickel less than
uh, palladium.
palladium, less than platinum. And other groups, the third element is the highest. Here also the third element is highest, but here there is a difference. Third element, then first element, then second element. So there is a decrease from first to second, as expected from any other normal group. As you go down, the size increases and IE decreases. But at the end, the third element has the highest. It is due to the lanthanide contraction effect. This is particularly post-lanthanide. Size-wise, it was similar, as we were saying, similar. But IE-wise, the energy required to remove the electron, that wise, it is highest. Lanthanide contraction. All these also due to lanthanide contraction. And this is also same. But exception is the scandium group. There you will find there is a gradual decrease. Scandium, yttrium, lanthanum. You will find a gradual decrease because lanthanum does not experience the effect of lanthanide contraction. After lanthanum, when hafnium comes, then you will find, for example, group 4 you will write the yttrium group, sorry, the titanium group. Titanium group. Then you will say titanium, the highest is titanium, then titanium, अरे ता तलटा के
Zirconium.
zirconium
Zirconium.
Zirconium,
hafnium. So hafnium number
hafnium.
1, तापरे titanium, तापरे zirconium. You will see all these things. Titanium is greater than zirconium, but hafnium is the highest. Same you will find vanadium already you have done. That is an anomaly. It goes on increasing. That is why I have told it in the beginning. Then chromium, vanadium, chromium already gone. Then chromium के बाद आ जाए manganese group, group 7. This is group 4, I'm sorry, group 7. This is the manganese group. कौन होगा? Manganese group रा सबुठु ये किए?
Sir, technetium,
Rhenium.
manganese, and
Rhenium greater than manganese, greater than technetium, which is radioactive, nobody bothers. Then group 8, that is iron group. Iron, cobalt, nickel, कौन होगा?
Sir,
osmium,
osmium.
iron,
Iron.
ruthenium.
Ruthenium.
Group 9 टा होची cobalt group. Okay.
Sir, iridium, cobalt, rhodium.
Then group 10 टा nickel group टा already जाइची. Nickel टा body जीव that is anomalous. This is anomalous, that is double anomalous. And nickel group छोड़ा तापर 11, that is copper group, coinage metals. Okay.
Sir, gold, copper, silver.
Yes. Then asila finally group 12. कौन? Zinc group,
Sir,
which are not
sir,
true transition
mercury,
metals.
zinc, cadmium.
तामाने जଣା पड़ुची एंटायर पीरियडिक टेबल रे सॉरी डी ब्लॉक रे हाईएस्ट होची कारण कहली सीरीज रे लास्ट एलिमेंट हाईएस्ट बर्तन ଗ୍ରୁପରେ ଦେଖିଲା ବେଳକୁ ଥାର୍ଡ ଏଲିମେଣ୍ଟଟା ହାଇଏଷ୍ଟ, ତେଣୁ ମର୍କୁରୀଟା ହାଇଏଷ୍ଟ among D block elements. Now I will show you the original file which I have sent you perhaps. Have I sent this file?
Yes, sir.
Yes, sir.
See, of course this is a small table ignoring the D block. I said only showing the hump. And the highest IE in the entire periodic table is helium. Because in a period it increases, down the group it decreases. So you will find helium has the highest IE, having a duplet stable configuration, that is the highest. And the lowest is francium. Oh, I'm so sorry, cesium. Francium also has been studied. It is more than that, is another anomaly. That down the group it decreases, but here is an anomaly. The radioactive francium has been found to have greater IE than cesium. You know, that is due to relativistic contraction effect, most to do with quantum mechanics than anything which is qualitative, all quantitative. Of course, you can explain sometime. I'll tell you today, what is relativistic contraction effect. Now I'm showing you the graph. This we have already done. Hump, hydrogen, helium is the highest, then suddenly come down starting from the second period, lithium, then hump, boron, carbon, nitrogen, hump, then oxygen, fluorine, neon, then suddenly coming down to the third period beginning with sodium, but sodium has lower. See, lithium level is little more, sodium level is little less. Then again hump, magnesium sitting on hump, then aluminum, silicon, phosphorus sitting on hump, then sulfur, chlorine, argon, suddenly coming down. So potassium level is even lower than sodium and continues. You will read all these things. I have already explained to you, but we will transition series के बारे में मैं ज़्यादा डिस्कस करूँगा. In the first row, 3D series remains nearly constant up to chromium, then takes a jump at manganese. Again remains nearly constant and finally becomes highest at zinc. So grossly IE increases. Now see, 633, 659, 651, 653, এটা বড়িলা পুণ্টিয়ে কমিলা, so more or less same রহিলা 6 something, but suddenly manganese ର ଅଧିକା ହେଇଗଲା. This is 4s2 3d5. The cause is really not the cause cannot be really explained by any theory. Quantum mechanics can only solve the problem. You may say because 3d5 4s2, but you are actually removing electron from 4s. All these you are removing electron from 4s, not 3d. But 3D will have an impact because of the half field stability. It might will have some effect which we are unable to know. For which there is a sudden hike from 653 to 717. Chromium was 4s1 3d5. There was no repulsion factor. There was one electron. And of course, nuclear pull was only for 24 protons. It is 25 protons. So one electron that was having no other electron, you remove easily by spending 653. But when you come to manganese, you have an increased number of protons, now 25 protons, but you have some repulsion effect. So there is a pairing of electron in 4s. So to overcome that, you will need much greater energy. But suddenly, as it becomes D6, although you are removing electron from 4s, it comes down to, it goes on increasing. Then the nuclear charge takes sudden important prominent role, increases, and then remains more or less constant 7 को पळे आसिला 7 एटा 6 रे थिला सडनली मारिला जंप देन तापर जंप मार चलला तो जंप मारिला माने एटा सडन जंप तापर चलला स्लोली स्टेडीली बढ़िला 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 तापर हाईएस्ट हे गला जेतिकी similar but regular trends are found in other two series 4D मु ग्राफ भी अछि तारो एठी देखो मार्क करो जोटा 3D सीरीज टा ऑरेंज मोर ओले समान रहिला स्कैंडियम टू टाइटानियम टिके अधिका आई जो डेटा मु देइथिली स्कैंडियम एठी देइथिली स्कैंडियम 633 659 टिके बढ़िला तापर मोर ओले सेम रहिला स्कैंडियम टाइटानियम देखा पड़े टिके कमिला भी 8 क्रोमियम पर्यंत धर एई पर्यंत आमे तो कहबा मोर ओर लेस सेम सडनली मैंगनीज को बढ़िला तापर टिके टिके बढ़िला पुणी निकेल रे कमिछि टिके कमिछि पुणी बढ़िला टिके सडनली जिंक रे बढ़िगला सो यू फाइंड इन द सेकंड ट्रांजिशन सीरीज इट्रियम व्हिच इज लोअर देन स्कैंडियम नॉर्मल ग्रुप भलिया कमिला लांथनम आउरी कमिला सो यू फाइंड that zirconium has a lower value than titanium which we have already listed hafnium will be the highest you see hafnium jai kouti ଅଛି 5D series a hafnium is not seen anywhere yeah hafnium so yes it is hafnium आमे करथिले कोन ना सबुठ हाईएस्ट होची हैफनियम हैफनियम सेठी गोटे एनोमाली अछि हैफनियम टाइटेनियम संगे पाखा पाखी समान इफ यू लुक टू द डेटा सेठी गोटे एनोमाली अछि हैफनियम आउ टाइटेनियम मार्क करो 659 659 समान तो से किंतु जेहेतु ट्रेंड टा होची थर्ड टा हाईएस्ट मु आउ ताको थर्ड टा सब एलिमेंट हाईएस्ट सेटा सेतपे मु किछि कहिनी किंतु एठी लिखिदबा द रियलिटी इज आमे लिखिदबा एठी गोटे जो लिखिथिले टाइटेनियम ग्रुप रे आमे काहे कि जिंसटा ये करबा टाइटेनियम हैफनियम इज इक्वल टू एठी गोटे इक्वल टू लिखिदबा डेटा सब जगह तुम देखिबो हैफनियम संगे टाइटेनियम रो डेटा समान सब लिटरेचर जते प्रकार रो माने अलगा अलगा सोर्स सब अछि but you will find hafnium titanium saman sethipai you will find but in all other cases you will find a remarkable change in the position see the graph vanadium VC मु कहतली vanadium chromium and nickel माने बड़ी बड़ी जीवो the cause is not known vanadium to niobium अधिका niobium to tantalum third element गुडा सब ऊपर ऊपर अछंती कमिवा कथा समस्त कमिवा कथा समस्ते ऊपर ऊपर अछंती बहुत ऊपर अछंती बिकॉज ऑफ द एफ ब्लॉक कंट्रैक्शन कमिंग एट हैफनियम टा आसिला बोली किंतु सीए समान होची टाइटेनियम रे बढ़ुनी समान एक्चुअली इटे तळे अछि एक्चुअली दीटा को मर्ज कर जीवो खराब देखा जीवो बोली से तळे लिखिछि किंतु एक्चुअली गोटे पोजीशन रे से माने अन्य माने सब ऊपर अछंती वैनेडियम ग्रुप रे बड़ी बड़ी चलछि क्रोमियम मध्य बड़ी बड़ी चलछि वैनेडियम क्रोमियम एंड निकेल ग्रुप देखो निकेल मध्य बढ़िछि वैनेडियम टा गोटे हम्प रे हठात पळे आसछि एंड देनु बड़ी बड़ी चलछि बट अदर्स लाइक टाइटेनियम तो हमें देखिले समान हे गला हमरे नुवा डिस्कवरी देन कमिंग टू द क्रोमियम सॉरी वैनेडियम क्रोमियम तो गला आयरन ग्रुप सॉरी मैंगनीज ग्रुप मैंगनीज टू टेक्नीशियम कम एंड देन रेनियम सब टू अधिका सो रेनियम ग्रेटर देन मैंगनीज ग्रेटर देन टेक्नीशियम ठीक अछि आयरन ग्रुप आयरन इज ग्रेटर देन कौन greater than ruthenium greater than osmium iron greater than ruthenium second element ta to come then highest hoji or osmium greater than iron greater than ruthenium so the iridium greater than cobalt greater than rhodium cobalt ta second rhodium ta to come kintu iridium ta kintu platinum group re sei anomaly nahi mane joda prathame koithile it goes on increasing platinum greater than palladium greater than nickel it goes on increasing down the group gold रे पुणी anomaly हला gold highest then copper then silver copper to silver कमिला पुणी suddenly बढ़ी गला थर्ड रे and zinc ମଧ୍ୟ ସେଇ ଭଳିଆ ଜିଙ୍କ୍ ଠାରୁ କ୍ୟାଡମିୟମ୍ କମ୍, ହାଇଏଷ୍ଟ ହେଉଛି ମର୍କୁରୀ, ସବୁଠୁ ମର୍କୁରୀ ହାଇଏଷ୍ଟ। ଗଟ୍ ଇଟ୍? ସୋ ସବୁବେଳେ ଗ୍ରାଫିକାଲ ଆନାଲିସିସ୍ ଯଦି କରିଦେବ ସବୁଠୁ, ଆମେ ଏ ଗ୍ରାଫଟା ତ ଡ୍ର କରିପାରିବାନି, ଦେଖିବା ଖାଲି, ଏଇଟା ଡ୍ର କରିହବ ଦେଖିବା, କିନ୍ତୁ ଆମେ ଯୋଉ ଖାତାରେ
ସାର୍
ଲେଖିଦେଲେ। ହଁ।
ସେ ଯଦି ଗ୍ରାଫଟା ଦେଖେଇଲ,
ହୁଁ।
ସେ ସେଠି ଯଦି ଏଚଏଫ ଆଉ ଟାଇଟାନିୟମ ର ସମାନ ନିଆ ହଉଛି ପାଖାପାଖି,
କାହାର କାହାର?
ମାନେ ଏଚଏଫ
ଟାଇଟାନିୟମ,
ଆଉ ଟାଇଟାନିୟମ
ହଁ,
ଆଉ
ହାଫନିୟମ,
ହାଫନିୟମ,
ହାଫନିୟମ ଟାଇଟାନିୟମ ସମାନ।
ଆଜ୍ଞା, ତାହେଲେ ତ କପର ଆଉ ସିଲଭର ତ ଆହୁରି ପାଖାପାଖି ପୁରା କଥା ହଉଛି।
ପାଖାପାଖି ଅଛି ଯେ ତମେ ଯଦି ଡେଟା ଦେଖିବ, ଡେଟା ଦେଖ, କପରର 745 ଆଉ ଗୋଲ୍ଡର ହେଉଛି 890। ସବୁ ଜାଗାରେ ମୁଁ ବହୁତ ଅନ୍ୟ ବି ଦେଇଛି। ହୁଁ। କପରର ଏଇଟା ସେଇ ଜିନିଷ, କପରର 745, ହଁ, ଦେନ୍ ସଡନଲି କମିଲା 731। ଆଉ କପରର ସିଲଭର କଥା କହୁଛ ନା କଣ? ନା କପର ସିଲଭର କଥା
ଆଜ୍ଞା,
କହୁଛ? ହଁ,
କପର ସିଲଭର।
ଡିଷ୍ଟିଙ୍କଲି କମୁଛି। ସେ ଗ୍ରାଫର ପୋଜିସନିଂଟା ସେଠି ଯେମିତି ଲେଖିଛି ସେମିତି ଲାଗୁଛି, ଭାବୁଛି ତମ ଯେ ଦେଖ, ସ୍କାଣ୍ଡିୟମ ସାଙ୍ଗରେ, ସରି, ଟାଇଟାନିୟମ ସାଙ୍ଗରେ ହାଫନିୟମ ଏକଦମ ସମାନ, ଏକଦମ। while copper sangare silver is definitely convincingly silver ତଳେ ଅଛି, କପର ତଳେ ଅଛି, ଗୋଲ୍ଡ ବହୁତ ଉପରେ ଅଛି, ହେଲା, 890। ଗଟ୍ ଇଟ୍?
ସାର୍ ଆଉ ଗୋଟେ ହଉଛି ପାଲାଡିୟମ ଠୁ ଏଜି ବହୁତ କମିଗଲା,
ହଁ,
ସେଥିପାଇଁ
ପ୍ୟାଲାଡିୟମକୁ,
ଏଜି ସିଲଭର ବହୁତ କମି ଯାଇଛି ଗ୍ରାଫରୁ।
ହଁ, ପ୍ୟାଲାଡିୟମଟା ପୁରା ହମ୍ପରେ ଅଛି, ଗୋଟେ ସଡନଲି ହମ୍ପରେ ଅଛି। ୱେଲ୍, ବିକଜ 5s0 ସେଇଟା, ପ୍ୟାଲାଡିୟମର ଗ୍ରାଉଣ୍ଡ ଷ୍ଟେଟ୍ ହେଉଛି 5s0, 3d10, ହଁ, ସେଥିପାଇଁ 3D ର 10 କନଫିଗୁରେସନ ଷ୍ଟେବଲ ଫୁଲଫିଲ୍ଡ କନଫିଗୁରେସନକୁ ହାତ ମାରିକିରି ବାହାର କରିବାକୁ ଇଟ୍ ଇସ୍ ଟେକିଂ ଲିଟଲ ମୋର ଏନର୍ଜି ଦେନ୍ ଏକ୍ସପେକ୍ଟେଡ, ସୋ ଇଟ୍ ଇସ୍ ସିଟିଂ ଅନ୍ ଏ ହମ୍ପ। ବୁଝିପାରୁଛ?
ଆଜ୍ଞା ସାର୍।
So, but in most cases, the cause cannot be explained. କାହିଁ ଟିକେ କମିଗଲା ଦେଖ, ସ୍କାଣ୍ଡିୟମ ବଢିଗଲା ଟିକେ, ପୁଣି କମିଗଲା, ଏଇ ଯୋଉ ଟିକେ ଭେରିଏସନ ହଉଛି, କଜ୍ ଇଜ ନଟ୍ କ୍ଲିୟରଲି ନୋନ୍, ଆମେ ବ୍ଲଫ୍ କାହିଁ କରିବା? ସେଥିପାଇଁ ଆମେ କହୁଛୁ ମୋରଲେସ୍ କନଷ୍ଟାଣ୍ଟ ରହିଲା। ଏଇ ଯାକେ ମ୍ୟାଙ୍ଗନିଜରେ ହମ୍ପ ଆସିଲା, ଉପରକୁ ଆସିଲା, ତାପରେ ଚାଲିଲା, ଉପରେ ଉପରେ ଟିକେ ବଢି ବଢି ଚାଲିଲା, ଟିକେ 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 ବଢିଲା, ବଢିଲା, ହାଇଏଷ୍ଟ ହେଇଗଲା ଜିଙ୍କ୍, ଦି ଲାଷ୍ଟ ଏଲିମେଣ୍ଟ। ଓକେ, I think we are on the verge of completing that, but interesting ଜିନିଷ ଏଇଟା ଟିକେ କଲ ଦେଖିଆ। ଏଠି ସଲ୍ୟୁସନ ମୁଁ ଦେଇ ଦେଇଛି, କିନ୍ତୁ ମୁଁ ପଚାରିବି ଏଠି, ଡିକ୍ରିଜିଂ ଟ୍ରେଣ୍ଡରେ ଲେଖିବ ସବୁବେଳେ, ଡିକ୍ରିଜିଂ ଟ୍ରେଣ୍ଡ, ଡିକ୍ରିଜିଂ ଅର୍ଡର, ଏରେ ସେଇ କାର୍ବନ, ନାଇଟ୍ରୋଜେନ, ଅକ୍ସିଜେନ, ଫ୍ଲୋରିନ, ଏଇ ଚାରିଟା ଏଲିମେଣ୍ଟରେ, ଏରେ I1 ର ଏବେ I2 ର କରିବ। ଏଇଟା ହେଉଛି କ୍ୱେଶ୍ଚିନ୍ ନମ୍ବର 1। क्वेश्चन नंबर 2 से डिक्रीजिंग ट्रेंड रे आमे करिबा लिथियम, बेरिलियम, बोरन, कार्बन। प्रथम आडू नबा, कार्बन टा एटी कॉमन रही गला, लिथियम, बेरिलियम, बोरन, कार्बन, एमानकर मध्य I1 रो ट्रेंड जोटा आमे सिखिले सेटा I1 रो, I2 टा तुमको निजे को भाबियो पड़िबो, I1 बी रे I2 तको करो, मैं यूं गया यूं आया। I think I will stop, I mean pause. Hello and welcome back. So have you finished? Now see, let us just make a change, increasing trend, so that in a period, usually we know it increases, then when anomaly comes, position changes, so the category increasing trend कर दियो। So carbon first, our answer of a carbon less than कौन?
नाइट्रोजन
Are you kidding me?
Nitrogen.
Are you kidding me?
सर कार्बन ऑक्सीजन सेकंड का
Because the nitrogen is sitting in a hump.
यस
So
सर
it
कार्बन
has,
ऑक्सीजन
so oxygen has a lower IE than nitrogen, but greater than carbon. Because carbon is here, nitrogen is here, oxygen is here. And then fluorine. I have not brought neon. Neon still greater. এই চারটা ভিতরে আমি কম্পারিজন করছি তাহলে কার্বন কোন
कार्बन ऑक्सीजन
Oxygen.
তারপরে
Nitrogen.
नाइट्रोजन फ्लोरीन
সো আর পজিশনটা ଟିକେ ଗୋଟେ ଗୋଟେ ଆଗକୁ ଚାଲିଗଲା because it is sitting in a hump. Position is now improved, increased. But to find what is the trend in IE2, you have to look to ସେମିତି ସାଙ୍ଗେ ସାଙ୍ଗେ କଲେ ହବନି. କାର୍ବନ ଗୋଟେ ଇଲେକ୍ଟ୍ରନ ନେଇକିରି ନାଇଁ ଆଗ ଆମେ ଏଇଠି ଆନାଲାଇଜ କରୁଛେ ଏକ ନମ୍ବରର ବିଟା ଆମେ ତଳେ ଆନାଲାଇଜ କରୁଛେ ଏଇଠି କେମିତି ଆଗ କାର୍ବନ ପ୍ଲସ୍ ନାଇଟ୍ରୋଜେନ ପ୍ଲସ୍ ଅକ୍ସିଜେନ ପ୍ଲସ୍ fluorine plus गोटे इलेक्ट्रॉन परे तापर देखियो पड़ी इलेक्ट्रॉनिक कॉन्फ़िगरेशन कौन हैला इज देयर एनी स्टेबिलिटी फैक्टर इन्वॉल्वड is there any octet configuration involved duplet configuration involved which will need unusually high the subsequent IE that you have to see so it will be 1s2 2s2 2p थिला now it will be 2p1 हे गला सेइठु इलेक्ट्रॉन बाहर कले सेकंड IE हबो ଆଉ ଗୋଟେ वन ऑलरेडी पढ़ेछि नाइट्रोजन होची 1s2 2s2 2p2 सो हुंड 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 हंड 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 से पढ़ेछि 2 3 थिला नाइट्रोजन रे बर्तन एठी 1s2 2s2 2p3 एठी हाफ फील्ड स्टेबिलिटी आसी गलानी एठी 1s2 2s2 2p4 5 थिला 4 आसी गलानी हमें मोटे भूलिबानी न्यूक्लियर चार्ज बढ़ी बढ़ी जाउची द ट्रेंड इज इंक्रीजिंग बट देयर विल बी सम हम्प समवेयर यू विल गेट सो टेल मी एटा 1 एटा 2 सही हुंड हुंड एटा स्टेबिलिटी फैक्टर आसी गलानी 3 हे गलानी एटा 4 the Hapfield stability you are getting so what do you think where will be the hump
सर नाइट्रोजन ऑक्सीजन
सेठी नाइट्रोजन रे हम्प आस्थला एठी कोठी हम्प आसीबो
Oxygen.
स्वयं इज करेक्ट
Correct.
ऑक्सीजन हम्प आसीबो हम्प आसीबो माने ता परटा पछिकु पळेबो सो सेकंड आई आमे कार्बन रो नाइट्रोजन रो ऑक्सीजन रो फ्लोरीन रो सेकंड आई करूचे आमे एटा लिखि देले जानिबा पई कोन ताहले कोन हबो लिखिला बेलकु ओ ए सी एन सी लेस देन कोन एठी ओ आस्तला कोन हबो
नाइट्रोजन
तापरे
Nitrogen.
तापरे
ऑक्सीजन
Fluorine.
ऑक्सीजन
आर यू
Sir,
किडिंग मी
Fluorine. Sir,
फ्लोरीन
Fluorine.
देन ऑक्सीजन मोर ओवर एटी पी रे एठी तो अनपेड इलेक्ट्रॉन नाही ए सॉरी पेयर्ड इलेक्ट्रॉन नाही एठी गोटे पेयरिंग हुंड 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 पर पॉली आरंभ हलानी so because of that repulsion factor in the same orbital it will be relatively easier than oxygen to remove from the all the unpaired electrons they are not paired at all so 80 hump आसीगला hump is here तार पोजीशन टा आगु पळे आसला नॉर्मली जा आसबा कथा एटो अलगा चली आसला you got it you will see the value you will see the value I will show you the value for yourself सेमती लिथियम 2 नंबर रो IE1 पाई लिथियम लेस देन कोन
बोरॉन
बोरॉन because
Boron.
because beryllium is sitting on a hump तापरे beryllium तापरे
कार्बन कार्बन
तापरे नाइट्रोजन नहीं कार्बन आमे तो चारटा नहीं आमे तो चारटा नहीं कार्बन रे सरीगला बस सो दिस इज सिटिंग ऑन ए हम्प तो ता पोजीशन आगु चली आसला बट लुकिंग टू IE2 इटा A इटा B you have to look for Li plus BE plus BE plus C plus এটা 1s2 2s1টা চাଲି ଯାଇଛି 2s0 ହେଇଯାଇଛି। এটা 1s2 2s2 ଥିଲା 2s1 ହେଇଯାଇଛି। এটা 1s2 2s2 2p1 ଥିଲା ଏଠି 2p0 ହେଇଯାଇଛି। ଏଠି 1s2 2s2 2p2 ଥିଲା 2p1 ହେଇଯାଇଛି। ଆମେ ଭାବିବା ଇନକ୍ରିଜିଂ ଟ୍ରେଣ୍ଡ ବଟ୍ ସମଥିଙ୍ଗ ସମୱେୟାର ହାପେନ୍ସ। ଟେଲ୍ ମି କାହାର ସବୁଠୁ ହାଇଏଷ୍ଟ ହବ ଭାବୁଛ?
ଲିଥିୟମ।
Yes, because it has got the helium configuration, it will be unusual. Second IE to dislodge electron from a stable duplet will be enormously large. তুমি দেখুଛ helium ର ସବୁଠୁ highest. So ଏଇଟା ଲାଷ୍ଟ କୁ ଯିବ। ଏମାନଙ୍କ ଭିତରେ କମ୍ପିଟିସନ ହବ। ଏଇଠି 1 ଅଛି, ଏଇଠି 2 ଅଛି, ଏଇଠି P ରେ ଅଛି। ତେଣୁ ଏଇଠି କ'ଣ ଭାବୁଛ?
ତାପରେ ବୋରନ୍ ଆସିବ, ବୋରନ୍ ଫୁଲ୍ ଅଛି।
କାହିଁକିନା ବୋରନ୍ ଇଲେକ୍ଟ୍ରନ୍ ପେୟାର ଅଛି, ଷ୍ଟାବିଲିଟି ଫ୍ୟାକ୍ଟର ଟିକେ ରହୁଛି। ତେଣୁ ଗୋଟେ ପିରିୟଡରେ ବଢିବା କଥା, କିନ୍ତୁ এইটা 2s2 এইটা ତ କମ୍ ଅଛି। ଏଇଟା ତ ଆମେ କମ୍ପାରିଜନ ହବା ଆ ପରଟା। ଏଇଟା ଷ୍ଟାବିଲିଟି ଫ୍ୟାକ୍ଟର ଅଛି, ଏଇଟା 2p ଅଛି। ତେଣୁ ନ୍ୟୁକ୍ଲିୟର ପୁଲ୍ ଫ୍ୟାକ୍ଟରକୁ ଡେଫିନେଟଲି ମାର୍କ ଦେଇଦେବ ଏଇ ଯେଉଁ ଷ୍ଟାବିଲିଟି ଫ୍ୟାକ୍ଟର। ସୋ ଆମେ ଏକ୍ସପେକ୍ଟ କରୁଛୁ କ'ଣ? ଆଗ କିଏ ଆସିବ?
ଲିଥିୟମ, ତାପରେ ବୋରନ୍।
ଲିଥିୟମ ନା, ମୁଁ ଇନକ୍ରିଜିଂ ଟ୍ରେଣ୍ଡରେ କହୁଛି ଲେସ୍ ଦେନ୍
कार्बन
କେମିତି ହବ? ଏ କାର୍ବନର ପୋଜିସନ ଏଇ ବୋରୋନ ଆର ଭିତରେ ଏପଟ
ବେରିଲିୟମ,
ସେପଟ ହବ। ହଁ,
ସେଟା ବେରିଲିୟମ,
ୟେସ୍। ତାପରେ
କାର୍ବନ,
ୟେସ୍, ତାପରେ
ବୋରନ୍, ଲିଥିୟମ।
बोरॉन।
ହଁ ହଁ, ଲିଥିୟମଟା ବହୁତ ଅଧିକା। ଆମେ ସେକେଣ୍ଡ ଆଇ କଥା ପଢୁଛି, ସେଠି ଆଉ ପ୍ଲସ୍ ସାଇନ୍ ଦିଆଯାଏନି। ଇଟ୍ ମିନ୍ସ ସେକେଣ୍ଡ ଆଇ ମାନେ ୟୁନି ପଜିଟିଭ ଆୟନରୁ ଇଲେକ୍ଟ୍ରନ ବାହାର କରୁଛୁ। ଓକେ, now let us see to the data that we have analyzed here. Have our analysis any error, or we have rightly analyzed? Let's look to the data. ये data ଦେଇଥିଲି ଏଠି, କାହାର ଦେଇଥିଲି? ହଁ, লিথিয়ম, বেরিলিয়ম, ବୋରୋନ୍, କାର୍ବନ, ଏଇ ଚାରିଟାର ସେକେଣ୍ଡ ଆଇ କୁ ମାର୍କ କର। লিথিୟମର କେତେ ଦେଖାଯାଉଛି? ଏଇଟା କେତେ ଦେଖାଯାଉଛି? ଏଇଟା କେତେ?
7.30।
ଏଇଠି ଦେଖିଦେବା। লিথিୟମ ଏଠି ନାହିଁ, ଏଇଠି ଅଛି। ଏଇଟା ବଢିଆ ଅଛି। লিথিୟମର ସେକେଣ୍ଡ ଆଇ ଏଇ ସିରିଜ କୁ ମାର୍କ କର 7.3। ତାପରେ କ'ଣ କରୁଥିଲେ? ଆମେ ପ୍ରଥମେ କାହାକୁ କରୁଥିଲେ? ବେରିଲିୟମକୁ କରିଥିଲେ ନା,
ଆଜ୍ଞା ସାର୍।
आज्ञा सर।
1.7। ତାପରେ କାହାକୁ କରିଥିଲେ?
କାର୍ବନ।
ହଁ,
कार्बन।
2.3 କାର୍ବନକୁ। ହଁ କି ନାହିଁ ସ୍ୱୟଂ?
आज्ञा सर।
Then boron 2.4, because boron is sitting on a hump. Boron is sitting on a hump. କାର୍ବନଟା ତାଠୁ କମି ଯାଉଛି। Then finally ଆସିଛି lithium 7.3. Coming to carbon, nitrogen, oxygen, fluorine ଆମେ ଯୋଉ କରୁଥିଲେ, କାର୍ବନ ସେକେଣ୍ଡ ଆଇ, ସେକେଣ୍ଡ କୁ ଦେଖ, କାର୍ବନ ଲେସ୍ ଦେନ୍ ନାଇଟ୍ରୋଜେନ୍। ତାପରେ କି ଅଛି? ଫ୍ଲୋରିନ୍। ଏଠି ଡେଟା ଚେଞ୍ଜ ହେଇଛି, 3.7। ଦେନ୍ ଫାଇନାଲି ଅକ୍ସିଜେନ୍। ଫ୍ଲୋରିନ୍ ଏଠି ଅକ୍ସିଜେନଟା ହମ୍ପରେ ବସୁଛି ବୋଲି ଫ୍ଲୋରିନ୍ଟା କମି ଯାଉଛି ଅକ୍ସିଜେନ ଠାରୁ। ଏଇ ଡାଟାକୁ ଦେଖିଲେ ଏଇ ଡାଟା ବି ଦେଖ, କାର୍ବନ, nitrogen, oxygen, fluorine, second I. Carbon is 2.35, then nitrogen 2.86, then fluorine 3.37, then oxygen 3.39। ଏଠି କ'ଣ କରୁଛି? ସେୟା କରିଛି। ହଁ, ଏ ଦୁଇଟାକ ସେମ୍ କରିଦେଇଥିଲା, କିନ୍ତୁ ସେମ୍ କରିଦେଲେ ଆକ୍ଚୁଆଲ ଯେଉଁ ଆନାଲିସିସ୍ ପିଲାଙ୍କର ଦରକାର, ଏକଦମ ଆକ୍ୟୁରେଟ୍ ଭ୍ୟାଲ୍ୟୁ ଦରକାର। ସେଥିପାଇଁ ସେକେଣ୍ଡ ପ୍ଲେସ୍ ଡେସିମାଲକୁ ଯଦି ଆଣିବା, ଦେଖିବା ଡେଫିନେଟଲି ଅକ୍ସିଜେନର ହାଇଏଷ୍ଟ ୟାଙ୍କ ଚାରିଟା ଭିତରେ। ଅଫକୋର୍ସ ନିଅନର ତ ତାଠୁ ଅଧିକା, ଆମେ ତା ନିଅନକୁ ନେଇନଥିଲେ। କୋଉଠି ଦେଖୁଥିଲେ? ହମ୍ପ ଆସୁଛି। ସେମିତି ତମେ ବହୁତ ଅଲଗା ଅଲଗା କୋଶ୍ଚିନ୍ ସବୁ ପାଇବ। even for the locations from the locations of the elements in the periodic table, predict which will have highest I4. Carbon, nitrogen, boron ভিতরে I4 देखो I4 মানে 3টা ইলেকট্রন পড়েইছি কার্বন হব কার্বন 3 প্লস হব 1s2 2s1 এই দুইটা চালছি এটা গোটে চাল যাইছি নাইট্রোজেন হব 3 প্লস র 1s2 2s2 2s2 2p3 তিনটা জায়গায় চাল যাইছি 2p রু দেন ବୋରନ୍ ବୋରନ୍ ଥିଲା 1s2 2s2 2p1 ତେଣୁ ଏଇଟା ବୋରନ୍ ଏଇଟା ନାଇଟ୍ରୋଜେନ୍ এটা কার্বন 1s2 2s2 2p1 1s2 2s2 2p1 না 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 2s0 হয়ে যাইছি সরি ନୁହେଁ ଆରେ ହଁ କି ନାହିଁ ମୋ
ଆଜ୍ଞା ସାର୍
2s0 ତେଣୁ ବର୍ତ୍ତମାନ ଦେଖିବା କୋଉଟା ଡୁପ୍ଲେଟ୍ କନଫିଗୁରେସନ ଆସିଲା ବୋରୋନ୍ ନାଉ ବୋରୋନ୍ 3 ପ୍ଲସ୍ has now attained duplet configuration ତାର ସବୁଠୁ ହାଇଏଷ୍ଟ ହବ then between these two carbon nitrogen ପାଖାପାଖି ଅଛି ଏଇଟା full filled ଅଛି ଏଇଟା half filled ଅଛି କଣ ହବ
ତାପରେ ନାଇଟ୍ରୋଜେନ
ହାଇଏଷ୍ଟ କାହାର
ଅଧିକ
ହାଇଏଷ୍ଟ କାହାର ହାଇଏଷ୍ଟ କାହାର
ବୋରନ୍
ବୋରୋନ୍ ର ଆନ୍ସର ହଉଛି ବୋରୋନ୍ ର boron the fourth electron to be taken from the core মানে duplet configuration or octet configuration highest order যদি যে পচারিব fourth ionization energy order যে পচারিব boron greater than কি decreasing order greater than
নাইট্রোজেন
nitrogen greater than carbon বুঝিল স্বয়ং
ଆଜ୍ଞା ସାର୍
এটা অর্ডার I4 ର অর্ডর ସେମିତି ଏଠିକି ପଚାରିଛି I2 ଷ୍ଟ୍ରୋନସିୟମ ରୁବିଡିୟମ ର I2 ତମେ I5 ବି ପଚାରିଲେ ତୁମେ କିଛି ମାଇଣ୍ଡ କରିବନି ତମେ 4ଟା ଇଲେକ୍ଟ୍ରନ ବାହାର କରିଦବ ଆଗ ସିରିୟଲି ଯେମିତି କନଫିଗୁରେସନ ଲେଖୁଛ ନଟ୍ ମ୍ୟାଡେଲଙ୍ଗ ଅର୍ଡର ଯେମିତି ତମକୁ ଶିଖେଇଥିଲି ସେ ବାହାର କରିଦବ 4s ରୁ ଗଲା 3d ରୁ ଯେତିକି ଯିବା କଥା ମୁଁ କହୁଛି ଗୋଟେ ଟ୍ରାନଜିସନ ସିରିଜ ର 3d ଫାର୍ଷ୍ଟ ଟ୍ରାନଜିସନ ବାହାର କରିଦବ ବାସ୍ ତାପରେ କମ୍ପେୟାର କରିବ ତିନିଟା ଭିତରେ थर्ड आयोनाइजेशन में 2टा बाहर कर दो फोर्थ आयोनाइजेशन में 3टा बाहर कर दो फिफ्थ आयोनाइजेशन में 4टा बाहर कर दो तापर कंपेयर करिवो कार स्टेबिलिटी फैक्टर आसला कि हम्प्रे बसिबो कोन बसिबो सो एठी गोटे थिला स्ट्रोंटियम रुबिडियम एटा 5s2 5s1 तार सेकंड आई माने एटा जाईची एटा 0 हो जाईची एटा 1 अछि तो डेफिनेटली एटा 0 होईची माने सेटा क्रिप्टन कॉन्फ़िगरेशन पाई गलानी नोबल गैस तेणु डेफिनेटली रुबिडियम रो सेकंड आईटा स्ट्रोंटियम रो अधिक हबो कि नहीं रुबिडियम टू स्ट्रोंटियम अधिक हवा कथा इन ए पीरियड इट इंक्रीजेस that is I1 but I2 depends on after removing one electron what is the stability factor ହେଲା ବୁଝିଗଲା ତ
ଆଜ୍ଞା ସାର୍
ମୁଁ ଏଟାକୁ ଲିଭେଇ ଦଉଛି ବିକଜ ତମେ ନିଜେ କରିବ and after having discussed about IE, let us now list out what are the factors which affect IE. The effective nuclear charge, principal quantum number n factor जोटा down the group टा, octet or duplet configuration आसीगले stable आसीगले बहुत अधिका energy दरकार, screening effect, electron electron repulsion जोटा को सबू आसुची जो sigma jet star calculation करूचे, d block contraction effect कहीं की गैलियम रो टिक्के अधिका है गला एल्युमिनियम को and why all these fourth period elements in the p block they have not that much you can have a look to the data how middle row anomaly you will be experiencing in kuade gala 8 dekho mark karo boron to aluminum कमिला 801577 गैलियम रो टिके बढ़ी गला 579 किंतु अमानकर कमी कमी जाइछि किंतु देखो एटा 1086 एटा 786 केते कमिला किंतु एटा 762 एटा 1012 947 999, 941, 1251, 12, 1140, 15, 21, এইটা ଛାଡ଼, ଏଇ ଯେଉଁ ଚାରିଟା ଏଲିମେଣ୍ଟ ମେନଲି, ପାଞ୍ଚଟା ବି ଚଳିବ, ଏଗୁଡ଼ାକର ଯେଉଁ ଟିକେ ମିଡିଲ୍ ରୋ ଆନୋମାଲି ସକାଶେ, ବିକଜ ଦେ ଆର୍ କମିଂ ଜଷ୍ଟ ଆଫ୍ଟର 3D ସିରିଜ ଇଜ କମ୍ପ୍ଲିଟ୍। ସୋ ପ୍ରଥମ ଏଲିମେଣ୍ଟଟା ଗ୍ରେଟେଷ୍ଟ ଏଫେକ୍ଟ ପାଇବ, ତାପରେ ମଧ୍ୟ ଦେଖିବ ଯେତିକି ପରିମାଣରେ ଏଇଟା କମୁଥିଲା ସେଇ ପରିମାଣରେ ଏଇଟା କମିବନି, ଯଦିଓ କମିବନି। ସେମିତି ଡ୍ୟୁ ଟୁ ଲାନ୍ଥାନାଇଟ୍ କଣ୍ଟ୍ରାକ୍ସନ୍, ଦେଖ ଥାଲିୟମ୍ ଇଜ ଦି ସେକେଣ୍ଡ ହାଇଏଷ୍ଟ, ମଚ୍ ଗ୍ରେଟର, 558 is 589, which is only next to boron, more than aluminum. Same, lead has greater than tin. So you find here also decreases, but not that much. Decreases, not that much. Decreases, not that much. So here also we don't call it middle row anomaly. It's not it last row anomaly. Don't say that. But lanthanide contraction has an effect, which will be profound in a profound manner in the p block in thallium and to some extent in lead, but such effect is still there, so that the variation is less. So এটা আমরা দেখিলে ଗୋଟେ ଟ୍ରାଞ୍ଜିସନ୍ ଏଲିମେଣ୍ଟ ମାନଙ୍କର ସକ୍ସେସିଭ୍ I1, I2, I3 এটা ইনক্রিজ করে, নো ডাউট, ইন এ ভেরি স্টেডি ম্যানার ইনক্রিজ করে, বিকজ দি subsequent electrons are removed from n-1 d orbitals. প্রথম দুইটা তো ns, তারপরে পরে n-1 d রু গোটে পরে গোটে নিয়া যায়। Due to small difference in I1, I2, I3 values among each series, they have many horizontal similarities in each series along with vertical similarities. Group रे तो similarity रहिबो because their valence cell configuration are similar, but series रे भी similarity रहुची because I1, I2, I3, I4 they are more or less same, or the increase is very very less for all these elements. When I saying iron, I'm saying iron ro I1, I2, I3, cobalt ro I1, I2, I3, the change is very very small. ତା ଛଡ଼ା ବି ସିରିଜରେ ବି ଆମେ ଦେଖିଲେ ସଡନଲି ସିନା ବଢି ଯାଉଛି ମ୍ୟାଙ୍ଗନିଜରେ, କିନ୍ତୁ ତା ପୂର୍ବରୁ ସମାନ ଥିଲା, ମ୍ୟାଙ୍ଗନିଜ ପରଠୁ ମଧ୍ୟ ଟିକେ ଟିକେ ଅଳ୍ପ ବଢିଲା। So due to similarities in some of the transition elements in a particular series, scandium ରୁ ଇଏ ପର୍ଯ୍ୟନ୍ତ, କ୍ରୋମିୟମ ପର୍ଯ୍ୟନ୍ତ, ହଠାତ୍ କ୍ରୋମିୟମ ରୁ ମ୍ୟାଙ୍ଗନିଜ ବଢିଲା, ତାପରେ ପୁଣି ବଢି ବଢି ଚାଲ, so they show similarities in series as well as similarities. Not all 10 elements are similar, but some series পর্যন্ত ক্রোমিয়ম পর্যন্ত, তারপর ম্যাঙ্গানিজ রু এ পর্যন্ত, so some similarities in the series and also down the group. এটা অলরেডি আমি କରିସାରିଛେ, ଲାନ୍ଥାନାଇଟ୍ କଣ୍ଟ୍ରାକ୍ସନ ଏଫେକ୍ଟ ଆମେ ଦେଖିଛେ, ଫ୍ୟାକ୍ଟସ এটা ପଢିବ ନିଜେ, এটা ତାର ଆନ୍ସର ବି ଦେଇଛି, ତୁମେ ନିଜେ ପଢିବ, ଯୋଉଟା ନ ବୁଝିପାରିବ ମୋତେ ପଚାରିବ। ରିଲେଟିଭିଷ୍ଟିକ୍ କଣ୍ଟ୍ରାକ୍ସନ ଏଫେକ୍ଟଟା ମୁଁ ପରେ କହିବି। এইটা lanthanides and actinides রে in each series I remains nearly same. The variation is small as the electron is removed from a n-2 আগ আগ sorry, the electron is removed from ns while the n-1d, n-2f orbitals remain constant and they screen the ns electron which we are going to remove. So put screening effect with increasing z value while the n-1 ତେଣୁ z value ବଢିଲେ ଟିକେ ଟିକେ ବଢିବ, କିନ୍ତୁ 4f ଆଉ 5d ଏମାନେ ସ୍କ୍ରିନ୍ କରୁଛନ୍ତି କାହାକୁ ନା all the lanthanide elements 6s କୁ, ସେମିତି actinide elements କୁ 7s କୁ, ତେଣୁ ସେଥିପାଇଁ ତାଙ୍କର ବେଶୀ variation ହୁଏନି। increase nuclear charge ବଢୁଛି ମାନେ ବଢିବ, lutetium and lawrencium have the highest IE among the lanthanides and actinides respectively. ENC remains nearly constant and hence the variation is small in a series because yade nuclear charge बढ़ुची यार screening electron भी बढ़ुची in between screening electron छोड़ा 4f रे बढ़ुची 4f रे deeply buried तार screening constant अधिका 1 लेखा ତେଣୁ ସେଥିପାଇଁ effective nuclear charge remains more or less same or increasing very slightly but towards the end ବହୁତ ବଢି ଯାଉଛି ସବୁଠୁ highest. Actinides have slightly greater IE than lanthanides, corresponding lanthanide. So this is all about these SAQs ତମେ କରିବ SAQ ଗୁଡ଼ା ନିଜେ କରିବ ଆନ୍ସର ଦେଖିବନି. Why mercury is a liquid metal ତାର ମଧ୍ୟ ଆନ୍ସର ଦିଆହେଇଛି ପଢିବ. So I think we close today. I had a thought that I will finish electronegativity, electron affinity, at least these two, but didn't happen. Doesn't matter. We don't regret for that. We'll learn. କିନ୍ତୁ କଥା ହେଲା ମୁଁ ଯୋଉଗୁଡାକ କହିଲି ପଢିଦବ ରିଲେଟିଭିଷ୍ଟିକ କଣ୍ଟ୍ରାକ୍ସନ ଟା ମୁଁ କହିନି ସେଇଟା କହିବି ତଥା ପଢିଦବ ମର୍କୁରୀ ଇଜ ୱାଇ ମର୍କୁରୀ ଇଜ ଏ ମେଟାଲ ସେଇଟା ମଧ୍ୟ ଲେଖି ସେଇ ରିଲେଟିଭିଷ୍ଟିକ କଣ୍ଟ୍ରାକ୍ସନ ଇଫେକ୍ଟକୁ ଆଣିବାକୁ ପଡିବ ସୋ ସେଇଟା ନ ବୁଝିପାରିଲେ ମୁଁ କାଲି ନେକ୍ସଟ ଟାଇମ କହିଦେବି. So that's all for today.
Thank you, sir.
Thank you, sir.